Hey guys, today we're going to go over the answers for the review for your test. So let's start here. We're finding the area of our triangle. Remember, the area of a triangle is base times height divided by 2. So if I plug in this triangle's base, which is 27.6, and then its height, remember the height has to be perpendicular to the base, is 16, and divide that by 2. So I multiply those and then I divide it by 2. I get 220.8, and my units are inches squared. Remember, area is in square inches, or units squared, I should say. All right, and then we need the perimeter. Remember, the perimeter is just adding up all the sides. So I've got 32 for this length, 16 for this length, and 27.6 here. And once I add them up, I'm going to have 75.6 inches. All right, for the circle, remember circumference, you have two options. You can do pi r squared or pi d. Since we're given the diameter here, I'm going to use pi d. So remember, for pi, I plug in 3.14. It's a rounded approximation. That's why I have my approximately equal to sign. And then my diameter is 40. Okay, so that is approximately equal to 125.6 feet. And it's just a distance around, so the units would just be plain old feet, not squared or anything. Now, area of a circle, remember, is pi r squared. So for pi, I'm going to put in 3.14 again. The radius is half the diameter, so half of 40 is 20. And I need to square that, 20 squared. Okay, so that is 3.14 times 20 times 20 is 400. And then when I multiply those two together, I get 1,256 feet squared for the area of that circle. All right, now we're going to look at some composite figures, finding the area and the perimeter of each one. So the first thing we need to do is figure out these blank sides. So I need this length, and I see that this much of it is 15, and then this much of it is 5. So 15 plus 5 would make this 20 for this side. And then here for this length, notice this whole thing is 20, and this part is 16. So 4 would be what's left over. 16 plus 4 makes 20. All right, so for the area, I'm going to make this my first rectangle and this my second rectangle. So let's find the area of the first rectangle, and its length and width are 16 and 5. So this would just be 16 times 5, which is 80. And then for my second one, it's 20 by 15 for my second triangle, or rectangle, excuse me. 20 times 15. Make sure that you don't do 20 times 20. 20 includes this entire length, and I'm only looking at this part. So 20 times 15 is 300. And then the total area would just be those two added together. So 380. I put them together to make the total. Okay, for perimeter, I'm just going to add up all the sides. So I've got 20 plus 16 plus 5 plus 4 plus 15 plus 20 again. Okay, because this is also 20. When I add all those together, I'm going to get 80. And we don't have units here, but perimeter would just be plain units, and area would be units squared. Okay. All right, for our next one, we have a rectangle and half of a circle. So let's get our lengths first. So if this part is 8, then this part is also 8. And that means that our diameter of our circle is 4. Okay, so let's start with the area of the rectangle. This part right here would be 8 times 4, which is 32. And then let's do the area of the semicircle, Remember, area of a circle is pi r squared. And if it's a semicircle, it's just half of that. So we're going to divide that by 2. Okay, so let's plug in our values. Pi is 3.14. The radius, if the diameter is 4, then the radius is 2 squared divided by 2. Okay? And then when I put that in, 2 squared is 4. 2 times 2 is 4. I multiply 3.14 times 4 divided by 2. I'm going to get 6.28. So the total area is just going to be 32 plus 6.28, which is 38.28 units squared. Okay, for the circumference, the perimeter, we know these sides, but we don't know this. This would be the circumference of our semicircle. So remember, the circumference of a circle is pi times diameter, since we know the diameter, but this is half a circle again, so we're going to divide it by 2. Okay, so let's plug in our values. Pi is 3.14. Our diameter is 4. And we're dividing that by 2. When I do that, I'm going to get 6.28. I ended up with the same thing. Interesting. So this distance from here to here, this whole thing is 6.28 around that circle. So for the perimeter of the figure, I've got 8 plus 6.28 plus 8 plus 4. We add all that up, I'm going to get 26.28 units. All right, let's go on to the next page. And here, oh my, that's hard to see. All right, let me grab a new copy. Sorry, guys. Sorry, guys. I'm trying to grab another copy. All right, page 2, game on. All right, here we go. This is similar figures. So remember, for similar figures, I'm going to match up the two sides. So here I've got 5 centimeters, and here I've got 30 centimeters. So I'm going to go 5 is to 30, and then I'm going to match up these other two. Sorry, these are hard to read on the printout, but you've got your digital copy. X and 4. So if I did 530, I need to do X 4 here. Yeah, 530. Oops, I mixed it up. Sorry, this should be 4 over X. This video is becoming quite a nightmare, isn't it? All right, 5 to 30. 4 to X. Yep, okay, that works. So now remember that we need to cross multiply. Sorry, guys. 5 times X is 5X, and 30 times 4 is 120. Okay, then we solve for X. To get X by itself, I need to divide by 5. Okay, 5 goes into 5 one time, there's X. 120 divided by 5 is 24. So X equals 24 for that one. All right, now for this next one, remember I want to match up the two sides. So I've got X and I've got X minus 5. So I'm going to do X over X minus 5. And then the same thing over here. I've got 12 and I've got 8. So 12 over 8. Okay, so just make sure that you keep it consistent. We don't want to flip-flop our proportion, we'll get the wrong number. Then we are going to cross multiply. Okay, so I've got 8x on one side. And then remember, 12 times parentheses x minus 5. We're going to have to distribute that 12. So let's start solving. So 8x stays. 12 times x is 12x. and then 12 times negative 5 is negative 60. All right, now notice I've got an x term on this side and one on this side, so I'm going to need to move them. If I move the 8, I'm going to end up with nothing over here. I think I'm going to move the 12, so I'm going to subtract 12x from both sides. And I'll get a negative number, but that's okay. So negative 4x equals, these will cancel, and this comes down, negative 60. And then to get x all by itself, I'm just going to divide by negative 4. So it goes into itself one time, so that leaves x. And then negative 60 divided by negative 4 is positive 15. So x will equal 15 there. Okay. All right, so our next one is a scale drawing, and it is 3 inches to 9 feet. So that's going to be part of my proportion, 3 inches to 9 feet. And it says find the actual length if the drawing length is 21 inches. So wherever I put inches here, I have to put it here, 21 inches. And I don't know the number of feet, so it's x feet. Okay, then I just cross multiply. You don't have to worry about my units when I'm doing that. So 3 times x is, I'll do it over here, 3x. And then 9 times 21 is 189. Okay, now we're going to solve for x by dividing by 3. Okay, so x will equal 189 divided by 3 is 63 feet. Okay, now we're going to go on to finding the volume and surface area of each figure. Make sure that you just look for what's given. It's not always both for each one. So this one says find the volume of the pyramid. So remember, volume is the area of the base times the height, no matter what figure you're looking at. Okay, so our base is this square here. Okay, so our base is going to be 12 times 12. That's the area of that. And then the height is this perpendicular height here, 15. Okay, so when I multiply those together, 12 times 12 is 144. And then 144 times 15 is 2,160 centimeters cubed. Remember, volume has cubic units. Okay, here we're finding both the volume and surface area. So let's do volume first, since we just did one of those. Volume equals area of the base times the height. Now remember, when we're doing prisms like this, the triangle needs to be the base. Okay, so make sure that you use the triangle for your base. So the base of the triangle is 8 times the height of the triangle is 10 divided by 2. Remember, area of a triangle is base times height divided by 2. And then the height of the prism, if this is the base, flipping it on its head, the height is this length, 15. Okay, so when I plug that all into my calculator, my volume is going to be 600 meters cubed. Okay, now for surface area, remember we want to find the area of all the surfaces and then just add it up. So let's find surfaces that are like the triangle. There's 2 of those, right? So let's find the area of one triangle. That's base times height divided by 2. Okay, so 80 divided by 2, that's 40. And then there's these rectangles, and they're all the same. Let's see, they're not all the same. Ooh, this one's different. So this side is 15 by 9. This side is 15 by 9. The bottom is 15 by 8. So let's do area of the sides. And that will be 15 by 9, which is 135. And then let's do area of the bottom here. This would be 15 times 8. 40, 120. Okay, so there are two triangles, so we're going to multiply that by 2. There are two sides, so we'll multiply that by 2. And there's one base. Okay, so now we've got our 1, 2, 3, 4, 5 sides. Always double check that you've got all of them. So 40 times 2 is 80. 135 times 2, let's see. 135 times 2, 10, 11, 270. And then 120 times 1 is 120. So let's add those up. We've got 270 plus 120 plus 80. That's 470 meters squared for our surface area. Okay? All right, so that's our first 2 pages. Let's keep going. We are going to do this guy now. Okay, we are finding the surface area of this one. So remember the area of the square base. It looks like it's 1.5 times 1.5, which is 2.25. Okay, and then the area of these triangles, the base is the same as this, it's 1.5. The height of the triangle is 1.2, and we're dividing it in half. Remember, area of a triangle is base times height divided by 2. When we put that in, we get 0.9. Now we just need to figure out how many of each surface we have. So there's one square, and there are 1, 2, 3, 4 triangles. Okay, so we're going to have 2.25, and then 0.9 times 4 is 3.6. When we add those together, we get 5.85 meters squared. Okay, here we've got the volume and surface area of a prism. So remember, volume is area of the base times the height. So our base is 7 by 10, and our height is 16. So when we multiply that all together, we get 1,120 inches cubed of volume. Now for surface area, let's break it up. So the bottom and the top are the same shape. So let's pick one area of the top, and we're going to do 7 times 10, which is 70. Now the sides are 10 by 16. So let's do area of a side. It's 10 by 16, which is 160. And then the front and the back faces, we'll pick the front, is 7 by 16, which is 7 times 16 is 112. So there's 2 of each thing, right? Top and bottom, side and side, front and back. That's going to give us all of our sides. So when we multiply those out, 70 times 2 is 140. 160 times 2 is 320. And 112 times 2 is 224. When I add all those up, I'm going to get 684 inches squared. All right, angles. If angle A and angle B are complementary, remember complementary means they add to 90 degrees. And angle A equals 65. What does angle B equal? So basically we're saying if angle A plus angle B equal 90, and then we replace angle A with its measure of 65, we've got ourselves a nice little equation. Okay, so we can solve for angle B just like it's a variable. We can say minus 65 That will make those cancel. And over here, I'm going to put angle B equals 90 minus 65 is 25 degrees. Okay, next one, angle A and angle B are vertical angles. Remember, vertical angles are equal. So if it tells us that angle A equals 84, then guess what? Angle B also has to equal 84 because they are equal. Okay, here angle A and angle B are supplementary. Remember, that means they add to 180. And it says angle A equals 68, but we don't know what angle B is. So together, they need to make 180. Same deal. Treat your angle like a variable. Subtract 68. Angle B will equal 180 minus 68, 112 degrees. All right, we are going to use this set of parallel lines to do our last question. Grab. There we go. All right, so it says if angle 1, let me keep this up here so we can refer to it. Angle 1 equals 120 degrees. So this guy right here is 120. And angle 12 equals 115. So this guy right here is 115. Then find the other angles. So what I like to do is just start looking and see what I can see right away. I see these two are vertical, so they're going to be equal. And I see that these two are supplementary. They add to 180. So 180 minus 120 is 60. Okay, so right there I've got a few angles. Let's see if any of them are needed. Angle 5 is 60. Okay, angle 10, let's see, is there any relationship? They're on opposite sides, but they're inside the parallel lines. Those are alternate interior angles, so they are equal. So angle 10 is also 60 degrees. Okay, angle 14, that's supplementary with angle 10. So we saw 60 and 120 makes 180, so 60 and 120 makes 180. Number 11, make sure that's not a class coming. No, okay. All right, number 11. So let's start using this angle. These two are supplementary, and 180 minus 115 is 65. So number 11 is 65 degrees. Angle 8, let's see, what relationship? They're opposite sides, but they're inside the parallel lines. Those are alternate interior too. This is 65. They're equal. And then angle 3, those are vertical angles. They're equal. So that number 3 is 65 too. Okay. Now we're going to name the angle relationships for these angles. Okay, so we're still using these parallel lines. 11 and 16. So this 11, that's 16. Notice they're opposite each other at the intersection. These are vertical angles. 11 and 15. Notice these are right next to each other. They make a straight line. Those are supplementary. 3 and 4, also right next to each other, and they make a straight line. Those are supplementary. 5 and 13. 5, 13. Notice how they correspond to one another. They're the same angle, just at different junctions. Those are corresponding angles. And then 7 and 12, they're alternate sides inside the parallel lines. So alternate interior. Okay, let's keep moving on. This will be our last two problems. We're using this as our example. It says angle 1, so this guy, is 3x minus 17. And angle 2, this guy, is x plus 1. So let's see. Those are, if we kind of look at our parallel lines here, they're on opposite sides, but they're outside the parallel lines. Those are alternate exterior lines, or angles, excuse me. So we know that those are equal to one another. We can set up an equation. 3x minus 17 is equal to x plus 1. Now we just need to solve for x. Notice I have an x on this side and an x on this side. Put in your invisible 1 and get this to the other side by subtracting. 3x minus 1x is 2x. Bring down your minus 17. 1 minus 1 is 0. Bring down the 1. Okay, now here's my variable. Remember, I want to get rid of the constant first, so I need to add 17. I'm going to bring down my 2x. The 17's cancel. 17 plus 1 is 18. Again, finding my variable. Now I can divide by 2. So that x equals 9. All right, this guy, angle 3 and angle 4 are what we're looking at. Those are consecutive on the same side, interior, inside the parallel lines. So consecutive interior angles, remember, are supplementary. They add to 180. So if I take 20k plus 11 and I add 8k plus 1, they have to equal 180 because they are consecutive interiors. They're supplementary. Remember, for this guy, look on your left side, there's some like terms. I've got a 20k and I've got an 8k. If I put those together, I get 28k. I also have an 11 and a 1. Add those together, I get 12. Okay, same as before. Get rid of the constant first, so subtract 12. 28k is left. The 12's cancel. 180 minus 12 is 168. Final step to get k by itself is to divide by 28. So k will equal 168 divided by 28, which is 6. All right, guys, I know that was a mouthful. Thank you for hanging in there with me, and let me know if you have any trouble.